All right, Algebra 2, Unit 4.6 is on graphing rational functions. Rational functions graphing, we kind of talked about it real quick. I think it was back in Unit 1 when we talked about parent functions and all the different shapes. This one and exponential functions were two that I just briefly talked about at the very end. And I said that we would come back to these. So rational graphs are in Unit 4, and then the exponential graphs, we'll look at those a little closer second semester. So our rational graphs, there's only two shapes really that you have to make sure you understand how to graph them. These graphs can get real complicated depending on what how complicated the equation is. For you guys, I'm going to keep them pretty simple. So our graphs are going to look similar like this. Let me go ahead and plot up here on these two x and y axes. So rational functions for these basic shapes are going to be two curves. They're called branches. And they're always going to occur diagonal from each other. So that's one shape, and then the other could look something like this. All right, and so you can see the two graphs, or they're also branches, are diagonal from each other. There's always two of them. They never cross. They're going to go along what are called asymptotes. We're going to have vertical asymptote and horizontal asymptote. And all we're going to do is move these around left, right, up, down, kind of thing. All right, so here's this function, f of x equals 3x over x plus 2, just so you can see. We have this polynomial monomial term on top, and then the binomial on the bottom. So one thing that we can look at, if we look at the graph for the equation that's given, we have these two asymptotes. So we have a vertical asymptote located right here. This is our vertical asymptote. And then we have our horizontal asymptote over here. All right, so when we write the equation of an asymptote, we're always going to write the equation of a line, so it's either x equals or y equals. So for vertical asymptotes, since it's vertical, it's always going to be x equals. So for this graph that's shown, the vertical asymptote, since it goes through -2 on the x-axis, it would be x equals -2. Now, if you have the equation, you can see it's from the denominator. If you set the denominator equal to 0 and solve for x, you're going to get x equals -2, which is also the excluded value. Now, the horizontal asymptote, that's the horizontal line that goes through the y-axis, it's always y equals. Right, and we can see it's going through 1, 2, 3, positive 3 on the y-axis, y equals 3. Now, the way that we're going to get it's based off the degrees on the top polynomial and the bottom polynomial. And if we look at this equation that's given to us, we're going to talk about how to get the asymptotes more in just a little bit. But if you kind of look at the coefficients in front of the x's, there's a 3 in front of the top x, and then there's a 1 in front of the bottom x. And if you do 3 divided by 1, that's going to simplify down to 3. All right, and so that's why in this problem it's y equals 3. All right, now we can get the domain and the range of these graphs. Domain, again, we look at what vertical lines intersect the graph as we move left to right. And it's going to hit everywhere except where that vertical asymptote is for the domain. It kind of skips it. And then as soon as it moves past it to the right, it picks up the graph again. All right, so the way that we do the domain, again, it's going to be based off the vertical asymptote. We're going to say from -infinity, because that's where it starts hitting, all the way to the vertical asymptote, which would be -2. Now we're going to use parentheses because it will never hit actually at -2, but it gets close to it. And then union, okay, and then we pick it back up again as soon as we move it to the right of the vertical asymptote, and then it's going to continue to hit everywhere all the way to positive infinity. Likewise, when we do the range, we go bottom to top, and we can see on this graph, it's going to hit at -infinity. All right, and then it's going to hit everywhere as we move bottom to top, all the way up to the horizontal asymptote this time. And it's going to skip that horizontal asymptote, and then it'll continue to hit as we move up. So we're going to use the horizontal asymptote number to state the range. All right, so it'd be negative infinity to 3. Again, we're going to use parentheses and then union, and we'll pick it back up as soon as we pass 3, going up all the way to positive infinity. We're going to always use parentheses for domain and range, so you'll never have brackets on these. All right, so let's practice finding just a domain given an equation. So again, the domain is based off the vertical asymptote, and the vertical asymptote is based off the excluded value. So what makes the denominator 0? So again, if you set x plus 2 equal to 0 and solve it, you get x equals negative 2. All right, so our domain can be every number except negative 2. So we would say negative infinity to negative 2, union negative 2 to positive infinity. Number 2, okay, again, it's based off the denominator, the excluded value. So if we set x minus 9 equal to 0 and solve it, we're going to get x equals 9. So 9 is the number that it can't be. That's the excluded value. It's also, again, the vertical asymptote. So our domain, we would say from negative infinity to 9, union 9 to infinity. All right, so let's turn it over. And so here's how we find the asymptotes. Vertical asymptote, again, that's the easy one. Just set the denominator equal to 0 and solve for x. Okay, again, it's the excluded value to the problem. It's always x equals a number. All right, so make sure it's always x equals. So for example, y equals 4 over x minus 5. If we set x minus 5 equal to 0 and solve it, we're going to get x equals positive 5. All right, that's the vertical asymptote. Again, write it as an equation of a line. Now, the horizontal asymptote, that's a little trickier because there's actually 3 different cases depending on the equation that's given to you. Again, it's going to always be y equals. All right, so if we look at the top exponent and the bottom exponent, so that's the degree of the polynomial on top and degree of the polynomial on the bottom. That's kind of what we're looking at. There's 3 different cases that we can come up with. So one case is when the bigger exponent is on the bottom, meaning the bigger degree is on the bottom. In that case, the horizontal asymptote will always be y equals 0. All right, so for example, y equals 4 over x minus 5. That's x to the first power on the bottom. That's a degree 1 on the bottom. On top, if you just see a constant term, there's no x on top, that's really 4x to the 0 power. And x to the 0 power is 1, and 1 times 4 is 4. So there really is an x on top. It's just raised to the 0 power. You just never see it. So on top, the polynomial degree is 0. So when you have just a constant term, the degree is 0. On the bottom, it's x to the first, and it's a bigger exponent or bigger degree on the bottom in that case, so that's why it's y equals 0. Another case, we can say y equals 4x minus 3 over x squared minus 5. On top, 4x minus 3, the degree is 1, because it's x to the first power. On the bottom, it's degree 2, because it's x to the second power. Again, the bigger exponent is on the bottom. Right? So one thing you can kind of just to memorize for you guys, because I'm going to keep the equations pretty simple. If you just have a number on top and there's no x, just think of it, it's always y equals 0. All right, so that's case number 1. Let's put number 1 here. Now, case number 2 is when you have the same degree on top and bottom. Okay, so the degree of the polynomial on top is equal to the polynomial degree on the bottom. All right, now in that case, all we're going to do is take the coefficients in front of the x's and then divide them or simplify that fraction. And that's what happened on the previous problem at the very beginning with the graph. All right, so for example, y equals 4x over x minus 5. So the degree on top for 4x is 1, and the degree on the bottom, x minus 5, is also 1. And since they're the same degree, we take the coefficients in front. So that's 4 over 1. That's a 1 in front of the x. So this would be y equals 4 over 1, which is 4. For the second example, y equals 4x minus 3 over 6x minus 5. Again, they're both degree 1. Degree 1, degree 1. So we take the coefficients in front, 4 over 6, And then we can simplify that fraction. 4 over 6 simplifies to 2/3. So that would have a horizontal asymptote at y equals 2/3. So case number 1 and case number 2 are really the only two cases you have to memorize for this class. Now there is a case number 3. Now, I'm not going to ask you it on the test, but that happens when the bigger exponent is on the bottom. So just in case somebody were to ask, what's the horizontal asymptote if the bigger exponent's on top instead? Well, then it happens, there is no horizontal asymptote, so we just write none. All right, so you can see two examples where the bigger exponent is on top for both problems. Okay, so again, you only have to worry about number 1 and number 2, either the same degree or the bigger exponents on the bottom. In that case, it's y equals 0. All right, so we can also, again, find our x-intercepts and y-intercepts, just like we did with polynomials. So to find x-intercepts, we can replace y with 0 and solve for x. And I'm going to give you a shortcut on that also. And then to get the y-intercept, we replace all the x's with 0 and solve for y. All right, so let's go through each of these problems, and we can answer all these questions. And this pretty much leads us into graphing. So once we have all this information, we can go ahead and start plotting and graphing. All right, so number 3 here, vertical asymptote. So you got to start to memorize how do you find all this information, because it's all going to be asked on the test. All right, so to get the vertical asymptote, we set the denominator equal to 0, solve for x. All right, so x minus 6, set it equal to 0. Again, it's the excluded value, and so dx equals 6. Again, write it as an equation of a line. Horizontal asymptote, so this is where we're looking at the different cases. So on top, the degree is 1 because it's 2x to the first power. And then on the bottom, it's x to the first power. And so they're the same degree. So we take the coefficients in front of the x's, so 2 over 1. There's a 1 in front of that x. And so the horizontal asymptote would be y equals 2 over 1. Okay, the domain is based off the vertical asymptote number. So we would say negative infinity to 6, union 6 to infinity. The range is based off the horizontal asymptote number. And so this would be negative infinity to 2, union 2 to positive infinity. Okay. Again, you can memorize, because vertical asymptote has x equals, and domain is all based off the x values. And then horizontal asymptote is y equals, and the range is always based off the y values. So that's another way you can memorize it. All right, x-intercept. We replace y with 0, solve for x. So I'm going to show you what happens when we do that, and then I'll give you a shortcut on what you can do to solve it. All right, so we're going to replace y with 0 in the equation. All right, now we want to get x by itself. So what we would do is multiply both sides by the denominator, x minus 6. So this cancels. Now, when we multiply 0 times x minus 6, well, we should know that 0 times anything is just going to be 0. All right, and then to get x by itself, we can subtract 1 over. 0 minus 1 is negative 1, divided by 2. All right, so we get x equals negative 1/2. So the x-intercept is negative 1/2. So one thing that you can use as a shortcut is really, if you recognize where is this from in the equation, well, it's just the numerator. So to get the x-intercept, what you can do is just set the numerator, the top, equal to 0 and solve for x. Because the denominator is going to end up canceling out, and then when you multiply 0 times the denominator, it just goes to 0. So just remember, set the top equal to 0, solve for x. All right, now to get the y-intercept, we're going to replace all the x's with 0, solve for y. Okay, so y equals 2 times 0 plus 1 over 0 minus 6. Okay, order of operations, you do everything on top, get it down to one number, and then do everything on the bottom, get it down to one number, and then if you can simplify the fraction, you want to simplify it. All right, so 2 times 0 is 0, 0 plus 1 is 1. 0 minus 6 is negative 6. Right, so that's the same as negative 1 over 6. So that's our y-intercept, negative 1/6. Okay, all right, so let's do the next one. All right, so number 4, vertical asymptote, again, set the denominator equal to 0. Solve for x. X equals negative 8. Horizontal asymptote, you want to look at the degrees, top and bottom. Since there's no x on top, again, that counts as x to the 0 power, and it's bigger exponent on the bottom, because that's x to the first, and so this is going to be y equals 0. So again, memorize if there's no x on top, it's always y equals 0. All right, the domain, again, is based off the vertical asymptote number. So that'd be negative infinity to negative 8, union negative 8 to infinity. Range is based off the horizontal asymptote number. So negative infinity to 0, union 0 to positive infinity. X-intercept, you can set the top equal to 0, okay? So if we set the top equal to 0, now there's no x to actually solve, and since there's no x and 0 doesn't equal 4, that means there's no x-intercept. So we write none. Y-intercept, we replace all the x's with 0 and solve for y. Okay? So 4 over 0 plus 8. That's 4 over 8, and that's 1/2. So the y-intercept is positive 1/2. All right, so let's move on. Now let's go ahead and do some graphing. So let's answer all these questions first, just like we did on the previous two problems. Vertical asymptote, x equals negative 3. Horizontal asymptote, since there's no x on top, it's going to be y equals 0. And we can go ahead and start plotting this. So vertical, we're going to do a dotted line at negative through negative 3 on the x. Horizontal, y equals 0, so it's going to go through 0 on the y, which is right on the x-axis. All right, x-intercept, we can set the top equal to 0 and solve for x. Well, there's no x to solve, so there is no x-intercept. Y-intercept, replace all the x's with 0. Solve for y. 6 over 3 simplifies to 2. So we can plot that. So positive 2 on the y-axis, right there. Let's get our domain and range in there. So negative infinity to negative 3, union negative 3 to positive infinity. Range, negative infinity to 0, union 0 to positive infinity. All right, so that's all we have right now. So when you're graphing, you're always going to make sure that you have 2 points on each graph, okay, each branch. Now, I can see 1 point is in that first quadrant, so there is going to be a branch in that quadrant, and then the other branch will be diagonal from it. So what we're going to do for the additional points, we're going to make an XY table. So you need 2 points on each curve, right? So the curve that's on the right side, let's get that one. We already have 1 point. Now we need another point. So all our points that we're going to pick for x's are all based off where the vertical line crosses. So you need 2 points that are on the left side of the vertical line. So it's going through negative 2 here. And then you need 2 points always that are on the right side. So on the right side, we already have 1 point. That's when x is 0, 0, positive 2. And we need some other x value that's on that side. You can pick any x value you want as long as it's not 0 and it's not negative 3. All right, so you could use negative 2, negative 1, positive 2, positive 3, anything like that. Okay? So I'll use, just keep it kind of easy, I'll use positive 1. All right, so if I put positive 1 in for x, I'm going to go back to the original problem, and I'm plugging 1 in. So that's 6 over 1 plus 3. So that's 6 over 4, which is 3 over 2. And that's the same as 1.5. So if I plot that point 1 comma 1.5, that's going to put me right here. So with those 2 points, I can plot this one curve. Okay, again, the curves run along the asymptotes without crossing. Okay, so that's one curve right there. Now, I know the other one's diagonal from it. Now, you can't just guess where it's going to go. I want to see points. And so now we need 2 points that are on the left side of the vertical line. Again, you can pick any 2 points as long as it's on the left side of the vertical line. Again, it's crossing through -3, so we can pick any 2 numbers that are less than -3. So you could use -4, or -5, or -6, or -7. It's up to you. So I'll just use -4 and -5. Okay, again, we're going to plug them back in for x, and then find the y values. All right, so plugging -4 in for x, that would be 6 over -4 plus 3. So 6 over -1 is -6. I plot -4, -6. Okay, it puts this right down here in the quadrant that it's supposed to be in. So it means I'm doing the math right. And then I'll put -5 in for x now, back in the original problem. So 6 over -5 plus 3. So 6 over -2, which is -3. Okay, if I plot -5, -3, it'll put me right here. Okay, so now I can draw my other curve. Right, again, they run next to the asymptotes. They don't cross the asymptote. They don't touch it. Make sure that you don't curve your graphs around each other. So, for example, you don't want to curve it around like that. Okay, they run next to the asymptotes. Okay. So make sure you show 2 points on each curve, each branch. And those are based off where it's crossing the vertical asymptote, or where it's crossing the x-axis, based off the vertical asymptote. All right, let's do 6. Okay, so set the denominator equal to 0 to get the vertical asymptote. So in this case, it would be x equals 0. Horizontal asymptote, look at the degrees on top and bottom. So we do have an x on top, okay, and bottom, and they're the same degree. So you take the coefficients in front, 2 over 1, and that would be 2. So y equals 2. So we can plot this. Vertical through x equals 0. So here it's going to be right on the y-axis. Horizontal, y equals 2. X-intercept, set the top, or numerator, equal to 0. And solve for x. All right, so that's -3 over 2. For graphing, we could say -1.5. So on the x-axis, it's going to cross through -1.5, right there. Y-intercept, replace all the x's with 0, solve for y. So on top, 2 times 0 is 0, 0 plus 3 is 3. 3 over 0 you can't actually do, it's undefined. That means there's no y-intercept. Domain, again, based off the vertical asymptote. So -infinity to 0, union 0 to positive infinity. Range, based off the horizontal asymptote. So -infinity to 2, union 2 to positive infinity. All right, so now we'll make our XY table. All right, so we can see there's one point that's on the left of this vertical asymptote, and we can see the quadrant that it's in. And so that means there is a curve down there, and you can kind of think of quadrant 3. All right, and then the other curve is going to be diagonal from it, so quadrant 1, if you want to think of it that way. So again, you need 2 points on each curve. So if we use the point that's on the left side as one of the points, then all we have to do is find one more point that's on the left side. All right, so we already have negative 1.5 used, so we need some other x value. So you could use negative 1, you could use negative 2, you could use negative 3, negative 4. It's up to you. Okay. So I'll use negative 3. So plugging negative 3 back in for both x's, then we just simplify. I'll do the work right here. So y equals 2 times negative 3 plus 3, all divided by negative 3. So 2 times negative 3 is negative 6. Negative 6 plus 3 is negative 3, divided by negative 3 is 1. So negative 3 has a y value of positive 1. Apply it right there. So now I have one of my curves done, and we'll disconnect them. Right, and now we need the other curve in the diagonal quadrant. So again, it's based off where the vertical line crosses. So it's crossing through 0. So that means to get 2 points that are on the right side, we need 2 numbers that are bigger than 0. So you could use positive 1, positive 2, positive 3, positive 4. You need 2 points. Okay, so I'll just use 1 and 2. All right, so I'll take my x value, positive 1, plug it back in for both x's, and simplify it. So 2 times 1 plus 3 divided by 1. So 2 times 1 is 2, 2 plus 3 is 5. So 5 over 1 is 5. So I can plot 1 comma 5. And I'll plug 2 in. 2 times 2 plus 3 divided by 2. 2 times 2 is 4. 4 plus 3 is 7 over 2. And that's the same as 3.5. So 2 comma 3.5. Just right about there. Right, and now I can sketch my curve going through those 2 points and along the 2 asymptotes. Right. So again, when you're plotting your points, make sure each curve has 2 points on it. And they're all based off the x values that are on the left side of the vertical line and on the right side of the vertical line. And the 2 curves should always graph diagonal from each other. And if they don't, let's say you have points that are on top of each other or next to each other in the 2 quadrants, then your sign's wrong or you did the math wrong, and just go back and find your mistake. That's it.